relative velocity. So this is a very, very one-line chapter. And you must have seen a lot of questions which trouble you and children feel challenged. Relative velocity is just this much. Just see this. Velocity of A as observed by B is equal to VA minus VB. This is relative velocity, the full chapter. And understand this one thing, to complete it and give you a proper exact definition is, right now we have not written, what does this mean? I'll add a few things here. This means velocity of A as observed by B, or velocity of A with respect to B. You have to understand that here B is the observer. B is the observer. And when I write VAB, that means velocity of A as observed by B or with respect to B. When I'm not mentioning anything here, VA and VB, they are velocities of A and velocity of B relative to ground. Our general definition will be for the same thing. VAB can also be written as VAX minus VBX. X can be any frame. So velocity of A as observed by B is written as this, and this one equation is more than enough for you to understand the whole chapter. One has to understand this equation with clarity, and I'll show you how for every relative velocity problem, this much information is more than enough. Let's see. Let's understand this. Motion is always relative. Motion is always relative. So suppose I have a truck, I have a car, and I have a tree on ground. Now, with respect to the ground, the velocity of the tree is 0. With velocity of the car, suppose I give it to you as 10 meters per second. And velocity of the truck, suppose I give it to you, is 50 meters per second. Suppose these are the velocities. Now I want to find one case, which is velocity of, when I say velocity of truck is 50 meters per second, what does this mean? It is the velocity of the truck as observed by a person on the ground, who's still on the ground, and it is relative to the ground. So if nothing is said, it is understood. Now, I assume this direction to be x-axis, positive direction of x-axis. So I can say this is 50 I cap, a unit vector in that direction. Similarly, velocity of car can be written as 10 I cap with respect to ground, and velocity of the ground or the tree is 0. Now, if suppose right now the observer is a man standing on the ground, this was the observer. Now we decide that we want to observe the truck sitting in the car. So what do I need to find out? I need to find out velocity of the truck. I want to, the observer is this now, suppose. Now velocity of truck as observed by the car will be equal to what? It will be velocity of truck relative to ground minus velocity of car relative to ground, or for that matter, any frame it holds true. Now, this will be equal to 50 I cap minus 10 I cap. This will be equal to 40 I cap meters per second. You have to write the units. I'm just wanting to focus on making you understand this. Now let's understand what does this mean. Let's understand this. And you have to get this clear. So this means car is a person sitting in the car is an observer now. Observer is here. So if I want to get into the brains of this observer and then observe the truck, I will find the truck to be moving with 40 meters per second in this direction. And velocity of the car as observed by the car. What will be velocity of the car as observed by the person sitting inside the car will be equal to what? VC minus VC. It'll be 0. So the observer will find that he's not moving at all. So this person sitting inside the car will feel his velocity of car as observed by the person sitting inside the car is 0. Velocity of the truck as observed by that person is 40 meter per second. And this is what you have to understand, that when we observe anything, good evening everyone, children, please pay attention to the lecture and you will enjoy the lecture if you are attentive and understanding everything that I'm trying to tell you. Now, add. How do I add? Okay. Okay. Now let's understand more questions. Let's do more questions and understand relative velocity. If suppose I give you, so this was a simple question. Both the bodies were moving in same direction. Relative velocity, more questions based on the same topic. I just want to add few more pages to this. Okay, I will. Relative velocity in one dimension. Let's understand this. And we are working on that. Now, if suppose I give you, I have a body A moving in this direction with 100 meter per second, and there is another body B which is moving in this direction, B, with 200 meter per second. Everyone has to quickly tell me, and I want participation. What will be the velocity of A as observed by B? Please tell me quickly with proper magnitude and direction, both. Quick. I want the reply in the chat. Based on your response, I'll keep increasing the level of difficulty and questions. So please answer. What is the velocity of A? Perfect. Which direction, Soham? So I'll quickly do it. Yes, he's right. So velocity of A as observed by B will be Ishan. Good. I'm happy. I want all the children to be participative. I'm beginning right from scratch and I want everyone to be having this clarity. So please pay attention. Velocity of A as observed by B will be equal to velocity of A minus velocity of B in vector form. And you have to just keep values. Velocity of A is, you assume this direction to be x-axis, positive direction. And therefore, I can associate a vector I cap with it. I can associate a vector, I can write it as minus this I cap. Now, just put the values VA. VA will be 100 I cap minus VB. VB will be minus 200 I cap. Therefore, the answer will be 300 I cap. And now, if I want you people to understand who's the observer now, what will be the velocity of B as observed by B? It will be 0. Velocity of B minus velocity of B. This body B, who is now the observer is sitting here, he feels he's not moving at all. So the observer will feel he's at rest here. He's not moving. He will feel A is moving in this direction, positive X direction, and the velocity is 300 meters per second. And now, by now, everyone should have understood what is the meaning of relative velocity of A as observed by B. And if they are moving in opposite directions or same directions, you can easily find relative velocity. This was not a tough job. This was not something which is a challenge for anyone. Let's see what happens when we want to go beyond this. अब हम इससे आगे चलते हैं और उससे आगे चलने के लिए let me give you another question. If I want to rub this, I think I can rub this also using this. Yes, first lecture recording is available. It's there on the YouTube. And don't worry, we will share. It's there on YouTube. So it'll be, everyone can have access to it. Now, let me give you another question. Now, this question is, suppose I assume that this is x-axis. Wait, sorry. Suppose this is x-axis, this is y-axis, and I tell you that there is a man moving along x-axis and he is moving in this direction from the origin. His velocity is in this direction along x-axis 100 meters per second. I want everyone to answer this question. This is man A. There is another man who's at a distance of 500 meters and he is moving towards the origin along negative y-axis in this direction, and his speed is 100 meters per second also. Now, these are two people. One is A, one is B. A is at the origin, B is here, which is 500 meters away initially at t is equal to 0. This is the distance. You have to tell me what will be the velocity of B as observed by A. Everyone, please tell me. First, you tell me the magnitude and direction of it, and then we'll do something interesting out of it. Quick. Velocity of B as observed by A. Okay. The first lecture of mechanics, Parth says it's a private video. Neha, I request that you, why is it a private video? You can make it a public video. Why is it made private? I'm surprised. I have requested the team to make it public. The mechanics part 1 lecture. Okay. It'll be done. All of you, please answer. Yes. Dave has answered it. Minus 100 I cap, minus 100 J cap. Yes, that's the right answer. But there is something more to it, which I want. That thing that I want is, now you tell me how A finds B is moving in which direction. Just show me on paper. Try to plot that on paper. So, try to plot how A finds B to be moving on your. Okay. So this is A and this is B. Now let's see how A is feeling about the whole thing. So we are going to get into the mind. No, 100 is not the answer. 500 is not the answer. So all these Mani Raju, Shweta, Nitra, 100 is not the answer. You have to understand this. VBA, velocity of B as observed by A will be equal to VB vector minus VA vector. And if you note it down, put the values, VB vector will be minus 100 J cap minus 100 I cap. This will be velocity of B as observed by A. This will be the answer. Those of you who have written it correct, they are understanding everything. Those who have not written it correct, they need to understand what they went wrong with. Now, I want you to understand this. Thus, what will be the velocity of A as observed by B, as observed by A itself? It will be velocity of A minus velocity of A, that will be zero. Now, because they are not acting along the same line, because they are not acting along, so 100 and 200 is a wrong answer. Please pay attention, everyone. One is I cap, one is J cap. This is J cap, this is I cap, and you cannot say it becomes 100 or 200. This will be using Pythagoras theorem, we'll get the answer. Anyways, coming back to, I am wanting to show you. So A will find that velocity of A as observed by A will be zero. So A will feel I am fixed here. I'm not moving at all. So A is going to feel in his brains that he's not moving at all. How will he find B to be moving? B will be having these two components in its velocity. So minus 100 I cap, that means in this direction it'll have 100 meter per second, and in this direction it'll have 100 meter per second. If you find the resultant of these two, B will be appearing to move to A in this direction. This will be the direction in which he will find that B is moving. If I plot this line, if I just draw this line properly, so he is feeling, A is feeling that moving, B is moving along this line, and he is at rest. This is how we'll find A to be moving. A is here, fixed, and B is moving in this direction as observed by A. This is how the relative motion is felt. Now, if I ask you, what is the closest distance they will come? What is the distance when they come closest to each other? So, if all of you can understand this, I drop a perpendicular. If A is at rest, B is moving along this line, then the closest distance on this line will be the perpendicular that is dropped from this point on this line. This will be the closest distance. Let's call it AX. Yeah, A, X only. Let's call this point X. I just wanted to avoid X because X axis is a confusion now. Now, I can call it AG. AG. AG is the closest distance, and this is a very beautiful solution. If you want to find the closest distance of approach between these 2 points, yeah, I will do similar such questions, more such questions. Either you do such questions by using calculus, or you do them by relative velocity, and it's a very beautiful solution to understand. How do we find this? If you can tell me, how many of you got this, that the closest distance will be AG, when they are closest, the distance between them will be AG? How many of you got it? Please raise your thumb, give me a thumbs up, because I feel that many of the students find it difficult to understand this part. If anyone has understood it, I'll be very happy. If not, I'll explain it again, I'll repeat it again. It's a very, very beautiful application of uh, relative velocity. Okay, I'll do it. Just try to understand the solution, and then we'll do a very, very beautiful problem based on the same thing. Okay, I'm going to rub this, and I'm going to do another question now, so that you have a very fresh perspective about the same approach. Now, I'm not solving for the perpendicular distance right now. Otherwise, if those who are understanding it, they can get it, that they have to just find this angle. They know this is 100, this is 100, so this will also be 100, and this angle will be 45 degrees. And if this is 45 degrees and this is 500 meters, this was 500 meters initially, and this is 45 degrees theta. So 500 cos theta will be this GB, and 500 sine theta will be this. That will be, this will be 500 sine 45, sine theta. And we would have got the closest distance between A and B. Now just see, it was so difficult to understand that if this is x-axis, this is y-axis, and there is a man who started from a region and is moving in x direction with 100 meter per second, and there is another man who's at 500-meter distance and approaching the moving along the negative direction of y-axis, this is B, that their shortest, the closest distance is not going to be uh, so this will move ahead, this will reach here, this will reach here, say after some time, so the distance between them will be this. So if you try to do this question uh, through intuition or without using a systematic approach, you will not be able to find out what will be the closest approach distance between them. But relative velocity empowers you that you can do this question, and it's a very beautiful application of relative velocity. And I will be repetitive, I don't mind doing it again. I am going to give you another question based on this. So how do I rub this? I'm not getting that option of creating a new template. One sec. Use eraser. Okay, that I can. I thought I have a shortcut. Okay. This I can. So let me give you, can anyone guide how I can erase the whole page at once? This is going to be tough. Can anyone tell me? Yeah, I will be giving you another question. I could have taken a new page. What I was told. Okay. There was an option. How can I create a new page? How? Use eraser on top. Clicking on three dots. I am doing that. I reached this part. Now, quick share or publish to gallery. What? Click on the right side icon. Right side icon. Which icon? Right last icon. View settings or template settings. Can you name which I should click on? Template settings or view settings? Which one? Not from this window. Okay. Then which window? I have to go back. Last right icon. Last right. Next to three dots. This one. Now, learn. What is this, man? Next to this one. This. Page add sign. Page. Can you be a little descriptive? Now click on three dot. जो page के. Okay. Now नीचे आ रहा है. पेज के नीचे आ रहा है. I'm sorry, let's not struggle with this. Acha, okay, this one. Yes, got it. I was taught this. Now I'll have no issues. I'm adding a few pages. Okay. Back. Now, let me give you another question, and all of you please be attentive and try to do this question. If I tell you that there is a man moving along x-axis. There is another man moving along y-axis. The man moving along the x-axis is here. He is moving, he is at a distance of 1 kilometer from the origin, and he is moving in this direction with the velocity of 100 meters per second. I'm going to keep the values simple so that calculation is easier. And there is another man who is, this is man A. There is another man who is moving right now. He is also at a distance of 1 kilometer from the origin. And this is 1 kilometer. And he is moving towards this origin. And his velocity is 50 meters per second. This is B. You have to tell me. Can anyone tell me who will reach the origin first? This is easy. They both are at a distance of 1 kilometer from the origin initially at t is equal to 0. A is here at t is equal to 0. B is here. And A and B are moving in this direction. B is moving along the negative y direction with 50 meters per second. A is moving in positive x direction with 100 meters per second. Each one was at a distance of 1 kilometer from the origin. Just answer, who will reach, A or B will reach the origin first? Who will reach the origin first? Quick, A. This is a no-brainer. And yes, everyone can answer this. A will reach first. So you can also imagine and see that by the time B has reached half the path, half a kilometer, here A has already reached here, and then A will move away and B will still keep coming closer to the origin, and there will be a time when they will come closest to each other. So right now, finding A, VAB, VA minus VB, VB minus VA, that is a very easy thing. Now my question is, using relative velocity, tell me, after how much time from the beginning, at t is equal to 0, they started. After how much time t is equal to 0, both of them started with constant speed, as shown in the figure. You have to tell me, after how much time will they be closest, and what is the closest distance between them of approach? When they will be closest, and what is that distance when they are closest from each other? What is the distance between them? Let me see who all can do it using relative velocity. Try to do it. And you have to understand that when you are using relative velocity, you have to think from the observer's frame. So if you decide A to be the observer, you have to think from his frame. If you decide B to be observer, you have to think from his frame. So you have to decide which one you want to be the observer and accordingly think. So give it a try. Give it a try. No, relative velocity is not 50 because, okay, 50 seconds. Someone is saying no, 50 seconds is not the answer. Explain again. Yeah, I am explaining. I have just given you a question. See, I'll be repetitive. I taught you velocity of A as observed by B. Please pay attention to this slide. I am going to again repeat. If someone has not understood, please see this. If there are two bodies and you want to understand the velocity of A as observed by B, it will always be equal to velocity of A minus velocity of B. Please understand this one equation. This is full relative velocity. And you have to also understand one more thing about it, that if nothing is mentioned, this is velocity of A as observed relative to the ground. Relative to the ground. But if suppose instead of relative to the ground, I end up giving you velocity of A relative to some frame which is x. So I can also, even then I can say velocity of A as observed by B will be equal to VA x minus VB x. X can be any frame of observation, and this will still hold true. So know these two velocities. And then I did some questions, made you understand. And now I'm giving you a question where I gave you a question where A is moving in along the x-axis in this direction with 100 meter per second, and it started 1 kilometer away from the origin. This was 1 kilometer. Same way, at the same time, B started. He's also 1 kilometer away from the origin, and he's moving along negative y direction, and his velocity is 50 meter per second. A's velocity is 100 meter per second. And my question now is, what will be the closest distance between the two when they come closest to each other? They will not meet each other. They will not hit each other. There will be a point, there will be a time after which they will come closest, and after that they will start going far away. I want you to tell me when will they come closest and after how much time from the beginning. T is equal to 0, they started the motion from these respective A and B points. You have to tell me after how much time, and they will come closest, and what is that closest distance of approach. Try to do it. I can see some people trying to answer. That shows that they are trying to work on it. But at the same time, if you pay attention and see the solution, it will help you big time. I will show you the solution. I will make you understand how to look at such problems and get full clarity on these problems. So trying to draw a neat diagram and ensure that you understand this. Wait. So let's draw the diagram again. And okay, first thing is, can I write velocity of A in vector form? Everyone, please help me. What can I write velocity of A as? Can I write velocity of A is 100 I cap meters per second or 100 meters per second I cap, whatever. This is velocity of A. Is it correct? Yes or no? Yes, great. Now velocity of B will be minus 100 J cap. Yes or not? Those who are understanding, please Soham Patil to me. No. Of the velocity of B will be minus 100 J cap. Yes. Good. Minus 50 J cap. I made this intentional mistake. This will not be 100. This will be 50. Perfect. This will be minus 50 J cap. Yes, correct. So there are students who are very A will reach first, Vedika. We are not right now talking about who will reach first. A will reach first. A will reach the origin first. But right now, the thing that is being discussed is when will they come closest to each other, and what is that distance of closest approach? When they are closest, what is the distance between them? That is what we'll find out. Just first understand this. Velocity of A, velocity of B. Yes, we have written. This is, nothing is mentioned. What is it? It is relative to what? With respect to ground, yes, if nothing is mentioned. Now what will be the velocity? Who you want to be the observer, A or B? You people choose and tell me. You want the observer to be A or you want the observer to be B? And accordingly I'll explain, and you can choose any of them to be the observer and we'll get the right answer. Okay, you people want A to be the observer. Okay. So let me find out velocity. A is the observer. I am going to mark that. So I am saying this is going to be the observer. And I will find out velocity of B as observed by A now. Because A we have chosen to be the observer. Velocity of B as observed by A will be equal to what? Velocity of B minus velocity of A. Yes. I've chosen A as the observer. And now I'm finding the velocity of B as observed by A. So this is velocity of B as observed by A will be equal to velocity of B minus 50 J cap minus velocity of A which is 100 I cap. Now this can be written as minus 100 I cap, standard form, minus 100, minus 50 J cap, meters per second. And this is velocity of B as observed by A in vector form. And now this, how to use this? You have to learn how to use this. You have to be very, very good at it. Now I will tell you how to use this. One more thing in parallel, because we have chosen A to be the observer, velocity of A as observed by A will be what? This will be VA minus VA, there will be 0. So any observer finds himself to be at rest. And now let's interpret these two. We have become observer A now. A is the observer. So let's enter the mind of A and let's see how the whole motion is happening. The actual motion is happening that A will always be moving towards the positive direction of x-axis and continue moving like this. Actually, this is happening. B is continuously moving along the negative direction of y-axis and it will continue moving like this. But how will A, the observer, find the motion to be happening? That I want you to visualize and just have a look at it. So I am going to draw how A will be feeling about the motion of B. So this was the x-axis, this was the y-axis, and I said A is 1 kilometer away here, B is 1 kilometer away here. And now let's see how A finds. What is the velocity of A as observed by A? It's 0. So A feels he's not moving at all. And this is 1 kilometer. This distance is 1 kilometer, 1000 meters. This is also 1 kilometer. Now just see this. How is he feeling about B? How is B moving? So he finds B to be moving with this velocity. Velocity of B as observed by A, we found this out. It was minus 100 I cap minus 50 J cap. And I want to use this to plot how A is feeling, B is moving. B is moving with 100 minus 100 I cap. He is finding B is moving in this direction with 100 meter per second, and he is feeling B is moving in Y direction with 50 meter per second. This way. So minus 100 J cap, minus 50, minus 100 I cap, minus 50 J cap. So the resultant of B, he will feel, is in this direction. He will find B is moving actually in this direction. This direction. He will find B to be moving in this direction, and he will feel that he is at rest, he is not moving at all, and B is moving along this line and going like this. Now, we want to find, so this is being observed. This direction is the direction of velocity of B as observed by A. This person A, this observer, is feeling that B is moving along this red line. Now, my question to all of you is, we wanted to find when will it be closest. So first, let's try to understand what is this angle theta. How much is this angle theta? You can very easily tell me, if this is 50 and this component is 100, tan theta can be written as, tan theta will be how much? 100 upon 50. All of you can see that. 2. Theta will be tan inverse 2. So tan theta is 2. Let's just keep it there. We can find sine theta and cos theta using this info. Now, if I want to find what is the closest distance between them, if A is stationary and B is moving along this line, then B is moving along this line. Then when will these two bodies be closest? You drop a perpendicular from here. This angle will give you the answer. How do we find this closest distance? Let's assume this to be G. So AG will be the closest distance. And how do we find this? That's the question. So all of you know, if I join A to B, this is just geometry which is left now. if I draw a line, A and B are joined, you will find this angle you will know. This angle you will know. How much is this angle? This is 1 kilometer. This is 1 kilometer. So this is 45 degrees. This is 45 degrees. And you can easily say that this angle is 45 degrees. Whereas our angle which the resultant velocity was making this direction, this was theta. If you remember this angle was theta. Now, if this is theta, this is 45, this is theta minus 45. If this is 90, so this will be how much? This angle. You can calculate that. And if you know these angles, this angle or this angle, you can find this side, GA, AG. And that AG will be the shortest distance between A and B in their journey. Between A and B in their journey, I've just written in this short form, journey. Now, how many of you understood this? We can use the geometry, find AB. How many? And I can also find the time. If you can find AG, you can also find GB, this distance. Using the same geometry, trigonometry, you can find GB. If you can find GB, you knew the relative velocity came out to be the magnitude of BA is root of 100 square plus 50 square, which is 50 root 5 meters per second. And if you use this BG distance, BG, geometry say we'll find BG distance divided by 50 root 5. 50 root 5. So relative displacement divided by relative velocity will give you the time also. Now, these two will be the answers. Now, how many of you have understood this? Please tell me. Those who have understood it, please write yes. Okay. Those who have understood this concept, please write yes. Great. Great. Now let's move to the next question. Something similar, better, and you will understand relative velocity more on the next. If suppose there is a raindrop, there are raindrops falling vertically, this rain man problems and all. So let's assume raindrops are falling vertically downwards, and these raindrops due to air friction, if we just make Ramesh, and there are a lot of people who are saying yes, but there are some people who are saying could not understand. I will send you this recording also. And what I suggest is please try to invest some time and try to understand it. अगर नहीं आता है फिर से repeat कर दूंगा. अभी आप पहले यहाँ ध्यान दीजिए. दो questions मैं already उस topic पे कर चुका हूँ. Similar से it will become very boring. Now, raindrops are falling vertically downwards in the vertical direction and with a constant speed. Now, can a raindrop be falling with a constant speed? Because raindrop is free to fall, then if there is no air friction, then the raindrop will fall under acceleration due to gravity. It should have an acceleration due to gravity. It will keep accelerating and it cannot have a constant velocity. But if I assume that there is mg also, there is air friction also, and the air is very full of moisturizer and tiny droplets are falling, so I can theoretically I can say that the raindrops are falling vertically downwards. Suppose this is a raindrop, it's falling with a constant speed, say 10 meters per second, vertically downwards. Suppose I have told you that. Now, if a man standing on the ground observes these raindrops, this is a man standing on the ground, he observes these raindrops and he's standing still. Suppose in the first case he's standing still, he will find them falling vertically downwards. There is no confusion about it. But if the man is also moving in this direction and he is moving in this horizontal direction with 10 meters per second, now how will he feel that raindrops are falling? So this is simply a case of velocity of raindrops as observed by the man. That is what we have to find out relative to the man, how he is feeling that the raindrops are falling while he's moving. So this is a relative velocity question, and you can see I can assume this to be the x-axis, I can assume vertical direction to be the y-axis, and you can see I can write the velocity of man to be what? Velocity of man can be written as velocity of man is 10 meters per second I cap. Velocity of raindrops can be written as minus 10 meters per second j cap. You can see this very easily. Velocity of man, velocity of raindrops relative to the ground. Now, what will be the velocity of raindrops as observed by the man? That will be VR minus Vm, and VR minus Vm will be minus 10 j cap minus 10 I cap meters per second. And if you now try to understand this situation, who is the observer here? Man is the observer. What is the velocity of man as observed by the man? I'm being very repetitive, but to drill the point into your head that we are now thinking from the perspective of the man. We are now observing everything relative to the man. So how will man feel about himself? This is the man. What is his velocity relative to himself? It's zero. So he will feel he is at rest. He is not moving at all. उसको ये अपने आप को चलते हुए देखेगा ही नहीं. उसे लगेगा मैं रेस्ट में हूँ. How will he feel about the raindrops? He will find the raindrops to be moving with this velocity as shown. This is minus 10 I cap, minus 10 j cap. If I plot it vectorially, so the raindrops will seem to have 10 in this direction and 10 in this direction. Velocity 10, 10. Negative x, negative y. Now, if I find the resultant will be along this. So he will find the raindrops to be falling in this direction. He will feel every raindrop is moving and coming and hitting him at an angle. This is the direction in which he will find the raindrops to be moving. Can you tell me what will be the magnitude of the velocity of raindrops? What is the magnitude of VRM? Magnitude is 10 square plus 10 square, 10 root 2 meters per second. And he will feel all the raindrops are moving. And what is this angle theta which the raindrops are making with the vertical? What is theta? Tan theta will be, this is 10, so this is also 10. Tan theta will be 45 degrees. Tan theta will be 10 upon 10, which is 1, which is theta is equal to 45 degrees. And they will find that this raindrop is coming and hitting the man at an angle 45 degree with the vertical. Now every raindrop he will find is moving this way, so he finds the raindrops to be falling at an angle 45 degrees with the vertical. Now there is a question, if he has to hold an umbrella, in which direction he should hold an umbrella. Now let me tell you a very funny thing. I was taking a lecture in the morning in a classroom, and the child said, sir, let the raindrops be falling at any angle, I can still hold the umbrella as I wish to. So very valid, but if I give a condition that the man wants to hold the umbrella to save himself from the rains to the maximum possible extent, in that case he should hold the umbrella like this. If he is holding an umbrella, his umbrella axis should make an angle like this with the vertical, and if this angle is 45 degrees, this is also 45. His umbrella axis should make an angle 45 degrees with the vertical axis, and that's it. Now, this is another application of relative velocity. These are called rain man problems. Okay. Now, let me give you a question which will make you think about the raindrops, and a man. And it will be a little challenging question. And let me see if you are able to do it. I will do only two problems, and or maybe we can move because the relative velocity. I will solve one more. There is one more concept of relative velocity that I want to teach. So instead of doing too many numericals, let's just get the hang of it. Now, tell me one thing. If there is a river that is flowing, and this is a river, this is flowing, and its flow velocity is 100 meters per second. Suppose in this direction. If have you ever put a paper boat in a river? So if I put a paper boat, what will be the velocity of the paper boat? If I put a leaf, what will be the velocity of the leaf? It will be same as of the river, because there is no engine in this paper boat. So it will flow with the river and the velocity will be 100 meter per second. And this direction is called downstream. This direction, if somebody is moving this direction, that is called upstream. So the boat will move downstream with the same speed as that of the flow of water of the river, 100 meter per second. And now this direction is downstream, downstream. This, if someone is trying to move in this direction, that's called upstream. And we'll do questions based on that. So suppose I tell you, this is not a river, it's a swimming pool with still water. And there is a swimmer who can swim in still water with a speed of 200 meters per second. This is the velocity of the swimmer in still water, velocity of man, whatever you call it. So this is 200 meters per second, and he can swim with this velocity. The magnitude of it is 200 meters per second in still water. When the water is still, his effort can give him a velocity which is 200 meters per second. It can be in any direction, in whichever direction he is trying to swim. So now suppose the same man who could swim in still water with this velocity, speed, with this magnitude, if he enters this river and he tries to swim, suppose this man tries to swim downstream, what can be the maximum speed? What will be his speed when he is trying to swim downstream? It will be how much? 300. Yes. The river will make him flow with 100, and his own effort will make him flow with 200. And therefore, the net velocity, the net speed with which he'll be moving downstream will be 300. If he tries to swim upstream, what will be his net speed when he's trying to swim upstream? In this case, what will be his net speed? 100, because his effort will be in this direction, and that effort will be 200 in this direction, 200. And river will make him flow with 100 meter per second in this direction, 100. This is 200. So the net he will be swimming upstream with, his net velocity is going to be 100 meters per second. So this much everyone can understand very easily. Okay. Now let's understand what do we do with this. One second. Now, if suppose I give you the same river and I tell you this is that river, and I tell you this, there is a man who starts from this point. He goes downstream for 20 seconds. He moves downstream for 20 seconds. How much time will he take to come back? He started from A, reached B, and river is flowing with 100 meters per second. His swimmer's own velocity or speed in still water when he was swimming would have been 200 meters per second. So when he goes downstream, what will be his net effective speed? It will be 300 meter per second while going downstream. And I told you 20 seconds tak he swam and went downstream. How much time will he take to return back to the original point A? Dear children, Radhika, I'm really sorry. I am not knowing Kannada, so I can speak in English or Hindi, and that's why I've chosen to speak in English because that will help all the students. So please be here. Now, uh, let's see. How much is AB? How much was his velocity when he was going downstream? His net velocity was 300 meters per second. In 20 seconds, how much he would have moved? 300 into 20, velocity into time, speed into time. So the distance covered, this distance is 6,000 meters. Now, if he has to return back from B to A, while returning back, his speed. Another boy is saying complete Hindi में बोलो. भाई देखो मैं हिंदी में बोल सकता हूँ, but there is a group of students who wanted के sir you can English or let's not debate the language. ठीक है, मैं थोड़ी आज bear कर लीजिए. There are some students who wanted this to be in English. From next lecture onwards, मैं proper. I am from UP, from a village near Ghaziabad, so I can speak proper Hindi also. I can speak English also. So let today's lecture be in English. Next time onwards, we'll see that I'll try to use a mix of the two. मैं दोनों को mix करके बात किया करूंगा आगे से. Now just see this. So while returning, his net velocity upstream will be how much? When he is trying to swim upstream, तो उसकी net velocity क्या होगी? 100. Okay, thank you. हाँ. So upstream जाते हुए his velocity will be 200 minus 100, which will be 100. Now 6,000 divided by 100. So the total time he'll take to come back will be 60 seconds. And that's a very easy question. But now the next question we will be doing is going to be interesting. Just see this. And it's a very important concept. The same river which is moving with 100 meter per second in this direction, the river flow is 100 meter per second. 100 meters per second. The man is standing on one bank of the river. He wants to cross the river and reach exactly the opposite point. Now, these are standard cases given in books, but still, it's my duty to explain this to you. So a man is at A, he wants to reach directly opposite point on the bank. And to reach here, if he tries to swim in the direction like this, if he tries to swim in this direction, the swimmer's speed in this direction will be 200. A river will make it flow in this direction 100 in 1 second. And if you see in 1 second, it will be moving at an angle like this. So eventually he will be, if he's trying to move perpendicular to the river and try to reach B, he is going to swim at an angle and he will end up reaching here. So this is not the correct way to cross the river and reach directly opposite B. If that is the goal, if reaching B directly opposite to A on the opposite bank is the goal, then he has to invest, he has to swim at an angle. And that angle, suppose that angle is say theta. This angle is say theta. The swimmer, if the river was still, would have swam in this direction with 200 meter per second. If there was no flow of river, in that case, this would have been 200 meter per second. His velocity in this direction would have been 200 cos theta. I am assuming you know how to resolve a vector. And his velocity in this direction would have been 200 sin theta. Now, please pay attention. If his effort in this direction cancels the effort of the river in this direction, then 200 cos theta is equal to 100 meters per second. And this gives me cos theta is 1 by 2, which means theta is 60 degrees. So if he is trying to swim at an angle 60 degrees with this angle is 60 degrees with this bank, if he aims to swim at an angle 60 degrees, his velocity speeds or efforts component which will give him a velocity in this direction will cancel the effort of the river, and his net velocity will be zero. Please try to understand this. This is the swimmer's velocity in this direction. This is the swimmer's velocity in this direction. This direction. And this is the swimmer's velocity in this direction, 200 sine theta. If the river was still, 200 cos theta is the swimmer's velocity in this direction. If the river was still, if the river is flowing with 100 in this direction, the net velocity will be 200 cos theta minus 100. And we want him to be not moving along the river at all. We want this velocity to be zero. So 200 cos theta is equal to 100. This is why the speed of the river is 100, and his component of his velocity, component of his effort or speed along opposite to the river is 200 cos theta, and we are equating these two so that they get cancelled. Therefore theta is 60 degrees. So now in this case, if the man tries to swim at an angle 60 degrees with the bank, he will be actually not moving at all in the direction of the river. He will be moving exactly in this direction with the speed. How much? He will be moving in this direction. You will find him moving in this direction, and this will be his net direction of motion, and his speed will be 200 sine theta. Now, please pay attention. So, if the width of the river is say W, the time taken will be equal to W divided by 200 sine theta. That's it. And theta, we already know, theta is 60 degrees. So we can put this value here. And if width of the river is given, I will be able to find the time. And this was done to ensure that the man moves and reaches the exactly opposite point. How many of you understood this? Please please say yes. Those who have understood this concept, that to try to reach the directly opposite point on the bank of the river, he has to put an effort at an angle 60 degrees, and how we calculated that and how he reached there. Those of you who are clear about it, say yes. Okay, I can see quite a few people saying yes. Now, let's do another variation of the same thing. If suppose let's do another variation of the same thing, maybe this time you will understand. If by any chance in the previous case you have not understood it, okay, I'm speaking in English. Now, if the same river has a width of say some width, this width is W, and the river is flowing, and the velocity of the river flow is 100 meters per second. This is given. And the same boy who was swimming with 200 meters per second in still water, the boy would have swam 200 meters per second was his velocity of the man, speed of the man in still water. Now, if I want you to tell me, if I want this man to cross the river in shortest possible time. Now, the condition is not he's standing at A. The condition is not that he has to reach the opposite point directly opposite to the bank. This time, we want him to cross the river in shortest possible time. For that, what he has to do? उसके लिए देखिए क्या करना पड़ेगा उसे. If he is trying to swim at an angle theta with the bank as shown, His speed will be, this is 200 in still water. His component will be here 200 cos theta, and his component in this direction perpendicular to the river will be 200 sine theta. Now, if I, so net velocity will be, his net velocity in perpendicular direction will be, he will not be going along this line, he will be going at an angle, but he is now trying to, we are trying to find out what angle should he use to cross the river in minimum time. So if he is going to swim at an angle theta as shown in the figure, he will have a component of velocity in this direction, which will be 200 cos theta. In this direction, it will be 200 sine theta. Now, if I want to only study the motion, this motion perpendicular to the river, in this direction, his speed is going to be 200 sine theta. The width of the river is W. The total time taken will be equal to W divided by 200 sine theta. If you see, I want this time to be minimum. Now, my condition is not that I want to reach opposite. No, that is not my condition. My condition is I want to cross the river anyhow at an angle by swimming at an angle theta such that I cross the river in minimum time. So time is given by this. Width of the river is constant. This is constant. When sine theta will be maximum, time will be minimum. So it will be minimum when sine theta will be maximum. What is the maximum value of sine theta? Maximum value of sine theta is 1. So time minimum to cross the river will be when I have W by 200. That will be the time. And I am putting, in that case, sine theta should be 1, which means theta should be 90 degrees. Now, what does that mean? How he should be trying to swim? This man was going to swim at an angle theta with the bank, but theta came out to be 90 degrees. What does this mean? The man should try to swim at an angle 90 degrees. This is what is coming out to be the result. What does that mean? इसको समझ लीजिए. You should be clear कि man को अपना effort up perpendicular to the river लगाना है. So he will be trying to swim at an angle like this. He is putting his 200 meter per second, his full effort in this direction. And the river will make him flow with 100 in this direction. His resultant will come out to be like this. So, but at every point, his effort is directed perpendicular to the river. His effort is directed at an angle 90 degree with the bank. And at every point, he is trying to swim perpendicular to the river. Here also, everywhere. But resultant is going to be something like this. He'll reach here and will reach here in minimum time. And that minimum time will be this. When his whole effort is swimming perpendicular to the river. Now, there is some philosophy we can learn from here. And this philosophy is, if this flow is the flow of life, the river flow, and your effort you have to put in such a way that you don't clash any of your effort against the flow of life. In that case, you are always going to put all your effort in crossing the river, in achieving your goals, and you will cross the river in minimum time. Have you understood the philosophy part also? Please say yes if you have understood how the person will cross the river in minimum time. Those of you who have understood it, please. Okay, I can see some students are getting it. They are saying yes. I wish I had every student saying that, but maybe because you people are, we have a Herculean task. We want to finish a lot of topics today. So relative velocity, which people keep doing for weeks, we are trying to finish in few hours. So I do understand that it will take you. Thank you so much, Srinidhi, Sunita, and those who are understanding it. I will try to make it more and more interesting and effective. Now just pay attention. So children, I want to say something here. So मैं ना, मेरी भी 11th में ना मैंने बहुत टाइम वेस्ट किया था. एक्चुअली में क्या हुआ था, फर्स्ट डे इन 11th, और मेरे पीछे कुछ लोगों ने बैठ के एक किसी ने डायलॉग दिया. समवन सेड कि 11th तो पढ़ने के लिए नहीं होती है, 11th तो मस्ती करने के लिए होती है, एंड वी शुड फोकस इन 12th में बोर्ड्स होते हैं और तब पढ़ लेंगे. सो आई एंडेड अप वेस्टिंग बिकॉज ऑफ दिस स्टेटमेंट. वो एकदम दिमाग में बैठ गया और फर्स्ट 6 months मैंने वेस्ट किए. सो I have seen a lot of such cases that children end up, when they go to 11th, they end up wasting their first half, first portion of 11th, and they remain weak in these topics. And because this topic, mechanics, is like the basis of everything, so it's very important to cover these topics. And hence, I'm holding these lectures and trying to help and ensure that you people develop and understand the concepts and are able to solve questions. चलिए आगे चलते हैं. Relative velocity in 2 dimensions. So this was the Rain Man velocity in vertical direction, and man was moving in horizontal direction. That was a relative velocity in 2 dimensions. River swimmer problems, they are also, river is flowing in one direction, man is trying to swim in perpendicular direction. These are also 2 dimensional motions, and we can do Rain Man type questions and river type questions. Okay, we are doing that now. Now coming back to crossing a river, shortest path, shortest time. Now, I have given you some food for thought, some clarity about relative motion. I can do more problems, but instead, I will prefer that I have given you a taste of the concept. And as I insisted, the relative velocity was all about understanding this equation, that velocity of A as observed by B is equal to velocity of A minus velocity of B. And if you start understanding this, and this can be any frame. If nothing is written, it is ground. Otherwise, if I say velocity of A with respect to train and velocity of B with respect to train, you just keep those relative velocities with respect to train and you will still get the same value. So generally, this is the equation of relative velocity. And if you have understood this, if you have started understanding how to observe from the observer's mind, observer's brain, which we tried in some cases today, and you now go home and try to attempt questions based on this, I am sure there will be a little more conceptual clarity and you will be able to solve questions. If not, we will do more problems in the next lecture based on your feedback. So, Abhi, for the time being, I am moving on to the next topic, which is projectile motion. And quickly, let's finish this, because then in the next lectures, I'll be focusing on Newton's laws of motion, free body diagrams, and all those pulley and wedges and rotation and collisions. Trust me, all that is very easy. This was the थोड़ा सा ना less interesting part. This next part will be very, very interesting. So I will quickly finish the projectile motion today, and then from next class, next lecture onwards, we will start doing. And there is the pseudo force circular motion. We have to cover a lot. Please pay attention. Let's do it. Projectile motion. In the last lecture, I touched upon a little. I will still want to give you a quick input about projectile motion. See, projectile motion is if you throw a stone at an angle theta with some initial speed u. So this stone will not move in a straight line. It will go like this and fall down somewhere. And this motion is called projectile motion. And then you have questions, and it is a very, very simple topic. All you have to do is learn to, do you know resolution of vectors? What will be the velocity of u? What will be the velocity of u in initial velocity in horizontal direction? Can anyone tell me, if I want to resolve this vector u naught into horizontal direction, this velocity will be how much? Quick response. Yeah, u cos theta. I want everyone to know this much. Only then you will understand everything else. U cos theta. So horizontal, initial horizontal velocity will be u cos theta towards right. Perfect. What will be initial vertical velocity? Initial vertical velocity will be u sine theta upwards. This much we know. Initial velocity. Great. Vedika, Avdut, Good. Just please pay attention, Bajjo. You will in no time understand this concept and you will be able to solve all the problems. And then a little practice will be needed, but just quickly trying to move on. So now, if I tell you, I want you to tell me what is the total time of flight. Suppose I gave you this question. From here, this is the initial position. Let me mark the initial position as I, and this is the final position. I want you to find what is the total time of flight from here to here. To find the time, generally you will be dealing with vertical motion, and I can do that. Yes. Now, let me study. So there are two types of motion. So this body, when it is in air, it has one force acting on it, which is mg, and because of that, the acceleration is g downwards. Does this body always have a uniform acceleration, and that acceleration is g downwards throughout its motion, and there is no acceleration in horizontal direction? How many of you agree? There is no acceleration in horizontal direction, and the vertical direction has g downwards. That's the acceleration, because the earth is pulling it with mg downwards, so the acceleration is g downwards. So it has vertical acceleration, it has zero horizontal acceleration. How many of you agree to that? Yes. Great. Now, in this motion, all we have to do is we will be seeing that the horizontal velocity will remain constant. It will not change. Why will it not change? Because there is no horizontal acceleration. So if I find out the time of flight from I to F, if I find out for how much time it was in air, at all the times, the velocity of this body at every point was horizontally, its velocity remained constant, and it was u cos theta. At the highest point, at the topmost point also, the horizontal velocity will remain u cos theta. Just before hitting the ground also, the horizontal velocity will be u cos theta. Please try to understand this. Now coming to the vertical velocity. You can see initial vertical velocity is this. Initial vertical velocity is this. And acceleration is acting downwards. This acceleration will decelerate, and this body will, the velocity will keep decreasing. And at the highest point, what will be the velocity of the body? At the highest point, vertical velocity will be quick. At the highest point, what will be the vertical velocity? Horizontal velocity will be u cos theta. What will be the vertical velocity at the highest point? Final vertical velocity. It will be zero. Yes, it will. Acceleration kept acceleration due to gravity, which was acting downwards. It kept on decreasing its velocity. Initially, the vertical velocity was upwards. It kept on decreasing it, and when it reaches the maximum height, it becomes zero. So we know this. Can anyone tell me what is the final velocity when it falls to the ground? I have seen a lot of people saying it is zero, but we will not consider that to be zero, because we are considering the points just after the body left my hand when it was thrown, and just before hitting the ground. So it will not be zero. So the horizontal, velocity after hitting the ground may be zero, but you never consider that. You consider the moment just before hitting the ground. So please pay attention and be aware of these things. Now, I want to find the time from I to F, from here to here, and we will, for that we will study the vertical motion. Let's study the vertical motion. Let's see what all do we know. Initial vertical velocity, u vertical, is how much? U sine theta upwards, meter per second. Acceleration in vertical direction, g downwards. For vertical motion from I to F, what is the vertical displacement? Can anyone tell me? What is the vertical displacement? Displacement in vertical direction. When it reaches from I to F, the whole displacement is horizontal. There is no vertical displacement. So vertical displacement will be zero. And I have to find the time of flight. I will use which equation here? S is equal to ut plus half a d square. 0 is equal to, I'm assuming upward direction to be positive. So any vector in downward direction will be negative. S is equal to ut plus half a d square u sine theta t plus half minus g t square. So you will be solving this. You will get a quadratic. T is equal to 0 is one solution, and the other solution is t is equal to 2u sine theta upon g. And that is the total time of flight. This formula generally for mains people remember, but I am totally against the formula. But even if you are remembering this formula, please understand this formula is the total time of flight when the projectile is moving from a point and it is falling back on the same height. If it is on the ground, it is falling back on the ground. Only then these formulae are applicable. If I change the paradigm, this formula, this direct formula will not be applicable. So from ground to ground or from same level of height to another, to the same level, then you can say the total time will be 2u sine theta upon g. And similarly, now let's do a different variety of problem and try to, so you could have found, if you have found the total time, you can find the range. What will be the range? Can anyone tell me? Range, this horizontal displacement. All of you know horizontal velocity remained constant, which was u cos theta, and time is 2u sine theta upon g. So the range will be equal to u cos theta into this time. So u cos theta into time of flight. This will give you the range. And if you solve it, the range will come out to be u square 2 sine theta cos theta can be written as sine 2 theta upon g. This will be the range. This is another formula that you remember. U square sine 2 theta upon g. Again, I am insisting that though you will remember these formulae for your mains, JEE mains questions, but for advanced, you will need the original approach, and this is applicable only when the body is falling to the same level, otherwise not. So please use the original approach of resolution of vectors and then try to solve questions. Otherwise, direct formulae should be avoided, and direct formulae only when they are falling from the same level to the same level. Now, if someone asks you, I want to find the this, I want to find the maximum height attained. If someone asks you this, now your initial point is this of consideration, final point which you are considering now is this. Between these initial and final points, can you say this maximum height that you are talking about is actually the vertical displacement of the body? This is the horizontal displacement of the body, and this will be the total displacement. So I am wanting to find vertical displacement of the body. So let's again study the vertical motion. If vertical motion, I am aware initial vertical velocity is u sine theta upwards. I am aware acceleration in vertical direction is g downwards. And I'm aware final vertical velocity will be at the highest point is 0, as I earlier explained. And I have to find the displacement in vertical direction, SV. Which equation should I apply? And I am assuming upward to be positive. So any vector downward will be negative. So we will use v square is equal to u square plus 2as. And from here, you will be able to get 0 square is equal to u square, u sine theta square plus 2 minus g s. And from here, you will get s is equal to u square sine square theta upon 2g. This is the maximum height attained. And this is another formula that people remember. But again, you will go mad cramming formulae if you don't understand the derivation, if you don't understand how we are achieving at these results, you will not be able to do much in IIT. So I am totally against formula approach. So even though I'm telling you, showing you how we are deriving these formulae, but I'm strictly again telling you, they may help you do some easy questions in your notebooks and study materials. But in IIT Advanced, you will have original questions. Now let's see if you have understood this approach properly. I'm giving you a question. Projectile launched horizontally. So suppose I tell you there is a building which is, say, 500-meter high and I launch a projectile. I throw a stone horizontally with 100 meters per second. Can you tell me what is the initial horizontal speed of this projectile? 100. And what is the initial vertical velocity of this projectile? Initial vertical is 0. Yes, Soham, good. Initial vertical is 0 and initial horizontal is 100. Now, I can give you very good questions also. So you can have a staircase where steps are made and you might have to find out which step it will hit. Abhi wo sab nahi karte hain, abhi simple karte hain. Let me just make you understand how you can. So this body will go and fall down on the ground. Please tell me how far and after how much time? After how much time and how far? What will be this distance? Let's call it range or whatever. X कितना होगा, T कितना होगा, ये बताइए अभी for the time being. पहले आप ये मुझे करेक्ट करके दिखाइए तो मेरा थोड़ा कॉन्फिडेंस बिल्ड होगा कि यू आर अंडरस्टैंडिंग थिंग्स एंड इट्स नॉट ऑल गोइंग इन द एयर. सो प्लीज टेल मी what will be the time it after which it hits the ground and what is how far from the building fit of the building is this stone going to hit the ground. Quickly try to solve it. I'm surprised there are so many children attending on YouTube also. Okay. If all of you who are attending, if you are understanding also, I'll be really glad. I'll be really happy. अगर आपको समझ में आ रहा है. Oh my God. Then, Abdut, what I'll suggest you is you can give me a call after the class and I'll try to convince your mom. Okay. Let's try to. Time is 10 seconds according to Aryan. How many of you did it? Okay. Let me solve it for you. Let's do it. So you can see if I want to find the time of flight, I can just study the vertical motion as you have seen in the previous cases also. Let's see what happens to the vertical motion. What is the initial vertical velocity of the stone? Here the velocity is purely horizontal. Initial vertical velocity is 0. So let me write it down. Acceleration in vertical direction is how much? It's g downwards. At every point, Earth was pulling it down, and the acceleration used was acceleration due to gravity, and that value is g. So I am writing it as 10 or g meter per second square downwards. What is the displacement in vertical direction? The body is going to come down vertically by how much? This much. This is the vertical displacement. 500 meters. So in vertical direction, the body will fall down by 500 meters. So vertical displacement is 500 meters downwards, and I have to find the time. We'll use G as 10 for the time being to calculate. Actually, value is 9.81 meter per second square. I do not want to waste time on calculating. So S is equal to downward direction. I can choose upward direction to be positive. I can choose downward direction to be positive, whichever. Let's choose downward to be positive. Okay. So this is plus, this is plus. This case, I'm just illustrating to you that you still get the same answer. Now, S is equal to 500 is equal to ut plus half gt square, which is 5t square. Ut, u is 0. So this will, now from here, you'll get t square is equal to 100, t is equal to 10 seconds. How many of you got 10 seconds? 9.8 or 10 seconds. Okay. Darshu got 10. Darshu Kalki. Vaishnavi got 10. Good. And here I have Yajat, Ishan, Aryan. Good. Any other person who got 10 seconds as the time of flight before it hits the ground? Please write down who all got this. Anyways, okay. Vaibhavi, Mahantesh, okay. Nidhi Shetty, very good. Good, good. Now, Soham, now, if 10 second is the time it was in air from here to here, if for 10 seconds it was in air from here to here, for all these 10 seconds, was its horizontal velocity constant or not? Yes or no? Was the horizontal velocity 100 meter per second constant or not? Because there is no acceleration in horizontal direction. Therefore, the total horizontal displacement, which is x, this will be 100 into horizontal speed into time taken, which is 10 seconds. So this will be 1000 meters. So x is 1000 meters. And if I ask you what is the net displacement of the body, the net displacement will be this. This is the initial position. This is the final position. The net displacement is the vector joining the initial position to the final position. And this will be the net displacement. This displacement had a vertical component, which was 500 meters downwards. It had a horizontal component, which is 1000 meters horizontal. And we calculated both. We calculated the time, we calculated the displacement. And it was a simple question where I was showing you a question. Projectile launched at an angle. And let me give you a question and let me see how many of you can quickly do it. And I am not going to give you a formula based question. So please try to do it on your own using the original approach. If I'm standing on a building which is 100-meter tall, you have to quickly do it. And standing here, if I throw a stone which is going to be thrown at an angle 30 degrees with 200 meter per second. And if I ask you, what is the total time of flight? It will go like this. It will not fall at the same level, but it will fall on the ground. And only one equation will give you the correct answer. If you have paid attention, tell me the total time of flight. After how much time will it hit the ground? And with this one question, I'll move ahead and we'll do other stuff. So you can see horizontal velocity will be 200 cos 30. Vertical velocity will be 200 sine 30 upwards. And you can see, you can just study the vertical motion and get the time. If you pay attention, vertical motion, we will write vertical motion. For vertical motion, initial vertical velocity is how much? 200 sine 30 vertically upwards. Acceleration in vertical direction is 10 downwards, 10 meter per second square. This is meter per second downwards. G I'm taking as 10 just to save time. And displacement in vertical direction from here to here, this is the initial position. Some people try to think it'll go and reach here. Let me find out the time for this, then I'll find out the time from there to here. No, you don't have to worry about all this. Just see the initial position, see the final position, and in between these two, this is the net displacement. This displacement has a vertical component which is 100-meter downwards, has a horizontal component. Now I am interested only in vertical displacement. So vertical displacement will be 100 meters downwards. And time I have to find out. And I will get this equation as is equal to ut plus half day square. I'll be able to solve it. I can assume downward direction to be positive. So I can say this is plus, and this is minus. And now S is equal to 100 is equal to ut. 200 sine 30 is 100 only. So minus 100t plus half at square, 5t square, 5 gets cancelled, t square minus 20t minus 40 is equal to 0. This will give you the answer. This quadratic equation you'll solve and you'll get the answer. So we are learning how to do projectile questions without applying formulae, just by resolving the velocity into horizontal and vertical directions. Now, if I give you, okay, what is the time of flight, maximum height, and range? These formulae I've already explained to you. And okay, there is one interesting thing I want to tell you. If you see this, if I threw a stone at an angle theta with the horizontal, and I found out the range. The range came out to be, there was this formula, range came out to be u square sine 2 theta upon g. That was the range. We calculated all that just few minutes back. Now, if I want to solve, I want to find what is the maximum value of range for any given theta. So at what angle should I throw a stone or a shot put or a javelin or anything so that I get maximum range? So for R to be maximum, because u is fixed, initial speed, g is a constant. So this value, if this is maximum, if sine 2 theta is maximum, then we'll get maximum value of range. For getting maximum value of range, sine 2 theta, it implies sine 2 theta should be equal to 1. Maximum value of sine theta is 1. Sine 2 theta should be 1. So 2 theta should be 90 degrees, theta should be 45 degrees. So you get maximum range when you throw a stone at an angle 45 degrees with the horizon. That is one result. So all these kind of interesting results. But if the moment I tell you, I am going to give you, throw a stone from a height. Now you cannot say that if you throw at an angle theta, theta will be 45 degrees for maximum range. No, you cannot say that, because that was applicable. This was applicable when the body was falling from ground to ground. So please don't generalize and cram things. Always follow original approach. Now, what is the equation of trajectory when we are studying the projectile motion? Again, if u and theta at an angle theta, I throw a stone and I want to find what is the equation of this trajectory, the path in terms of x and y. Suppose this is the origin, this is x-axis, this is y-axis. I want to know the equation of this trajectory. Iski equation nikalni hai. Very simple. After time t, at time t, suppose this point is x comma y. The body has reached here. What can I say about x? What can I say about y? X is the horizontal displacement, y is the vertical displacement. I can say x will be equal to horizontal component of the velocity is how much? U cos theta. U cos theta into time. What will be the y component? Vertical displacement. Vertical displacement will be s is equal to, what is the vertical velocity initial? U sine theta. S is equal to ut, upward positive, minus half gt square. Now, if you just calculate time from here and eliminate, put it here, substitute here, you'll get an equation in y and x, and that will be the equation of the trajectory. So y is equal to, time can be substituted as x by u cos theta. So it will become x tan theta minus half g t square, x square upon u square cos square theta, which is like sec square theta, cos square theta. I just substituted t from here in the whole equation, and I got an equation in y and x, and that is called the equation of trajectory. All of you should know this. They do give questions based on this, but how we derived this equation of trajectory was very easy. We just applied equations of motion. Now, special cases in symmetry. I don't know what special cases we referred to. Relative projectile motion. Yeah, this is also interesting. and very interesting because the questions based on this came in IIT. And this is not only for relative projectile motion. This is like equations of motion also. We can apply relative motion in one dimension. We can apply relative motion in two dimensions. And let me give you a glimpse and few questions based on that. Okay. So I think seeing the time, I don't think we'll be able to complete circular and pseudo force today. Maybe we'll cover them in the next lecture. Now, quickly see this. Let me do a simple question for you people for how we can use relative velocity for two-dimensional motion also and projectile motion also. So if I throw a stone from one building, if I throw a stone which is 100-meter tall, A throws a stone at an angle 30 degrees with 100 meters per second. And there is another building which is 200-meter tall, or let me make it a little, okay, 200-meter tall. And from the top of this building, I am going to throw a body horizontally with 200 meters per second, horizontally. So the vertical component is 0, horizontal is 200 meters per second. This is B. Now, this stone A and stone B, yeah, body A and body B will be in air. And you have to tell me that if they, I can ask you a very interesting question. What, after how much time they will come closest to each other in their journey? That is a question. And I'm giving this to you as a homework. Please write it down. The question is this. These are two buildings. They are, say, 1 kilometer apart. And this is 100-meter tall. This is 200-meter tall. And I am throwing a stone from stone A at an angle 130 degrees with the horizon and 100 meters per second. Say, there is another stone which I'm throwing horizontally with 200 meters per second, and I am giving you this as a homework. This is like relative projectile motion. So this can be IIT JEE advanced problem. So during their motion, they will be a point when they will come closest to each other. तो होगा क्या? देखिए, ये ऐसे जाके गिरेगा कहीं पे, और ये जो दूसरा पार्टिकल है ये ऐसे जाके गिरेगा कहीं पे. और ऐसा जरूरी नहीं है कि ये यहाँ पे इंटरसेक्ट करें या मिल जाएं कि सेम टाइम पे यहाँ पहुंचे. तो जब ये यहाँ पे था, हो सकता है ये यहाँ पे हो उस वक्त. ये देखिए, जब ये यहाँ पे था तो हो सकता है ये यहाँ पे हो. जब ये यहाँ पहुंचा तो भाई ये यहाँ और आगे पहुंच गया. जब ये यहाँ था तो ये यहाँ था. सो आपको ये नहीं पता कि ये जब 1 और 2 में था, या 1 डैश या 2 डैश में था, या 1 डबल डैश और 2 डबल डैश पोजीशन में था, किस मोमेंट पे दे वर क्लोजेस्ट. सो नॉर्मली it will become very difficult for you to find out when will they come closest. And it is actually a very good question if you, it can be an advanced problem. So just try to do this. K, in air, during their course of journey, before falling to the ground, what will be the closest they will come and after how much time? This is the question. And I'll be, okay, one child has already done it. Nice. Good. He used, Vihan, did you use the relative velocity concept? Did you study the projectile motion in terms of relative velocity, relative acceleration? Yes, very good. Interesting. Good. Let's see. Let's try to do it. I'll try to explain that to you. And I'm impressed that one child is understanding, and so fast he gave me the answer. So now it becomes my duty to try to do it. Okay. Now just see this. There is one method where I can get into relative velocity. Let's go back to our basics of relative velocity. If I go back to the relative velocity, they are thrown simultaneously. Just remember this. If I get into the mind of A, how will A feel about himself? Will he feel he's here only? This stone A is here only B is moving. Am I right or not? Velocity of A or acceleration of A as observed by A will always be zero. So A will feel that he is at rest. Are you all understanding what I'm trying to say? I am now going to get into the brain of A. I will observe the whole motion of B from the perspective of A, not from the ground. So when I go there, I will first thing I'll do is I'll go into the brain of A and see how is A feeling about himself. He is feeling that he is at rest. Now, velocity of A and acceleration of A as observed by A is zero. Now let's find out velocity of B as observed by A. Velocity of B as observed by A will be equal to VB minus VA. How can you write VB and VA? VB is minus 200 I cap. VB can be written as minus 200. I am assuming this direction to be the positive X and this to be the Y. So you can see velocity of B is in this direction and it can be written as minus 200 meter per second I cap. Everyone should know this. Now I want to write velocity of A. Velocity of A was 100 cos 30, which is 100 root 3 by 2, which is 50 root 3 I cap, 100 cos 30. Positive direction. Vertical direction is also positive. 100 sine 30, which is 50 j cap. This is velocity of A. Now, if I want to find velocity of B as observed by A, we are going to apply relative velocity in projectile motion. Just see this. So this is the observer now. A is the observer. Velocity of B as observed by A will be this. And this will become VB minus VA. So I will get minus 200 minus 200 minus 50 root 3 I cap. We'll take minus common and minus 50 j cap. Now let's try to understand what are we seeing. What is A feeling? What is this observer finding B to be moving like? So he is finding B to be moving with this velocity, which is shown in I cap j cap here. This velocity. And let's plot this velocity. So this velocity will have a horizontal component, which will be this much. Minus यानी कि 200 plus 50 root 3 in minus x direction. And in minus y direction, it will have how much component? 50. Minus 50 j cap. So he will find, A will feel he's at rest, and he will find B is moving in this direction. The resultant velocity will come out to be something like this. I'm just giving it to you here. He will find he's moving like this. Now there is another second part to it, this question. What is the relative acceleration of B as observed by A? This is going to make you feel how interesting this question is. Velocity of B as observed by A, we found out to be minus 200 plus 50 root 3 I cap minus 50 j cap. This was the velocity of B as observed by A. What is acceleration of B as observed by A? Who will tell me? Quick. What is the acceleration of B as a... Yes, Vihan, good. That's what... Okay. ठीक है. So acceleration of B as observed by A will be 0. Acceleration of B will be G. Acceleration of A will be G. Both are in air, both are falling down with in vertical direction with an acceleration A. So their accelerations are same. Therefore, acceleration of B as observed by A will be acceleration of B minus acceleration of A. And acceleration of B was G downwards. So minus 10 minus 10, and that meter per second square, and that count is 0. So very good. I am happy that a lot of you people, Shweta, Crazy Guy, Rishit, nice. I'm happy to hear this. And 0, 0, okay. Darshu Kalki, relative acceleration is not 9.8, it is 0. Swati, relative acceleration is acceleration of B minus acceleration of A. This is G, this is G, G minus G, it will be 0. So relative acceleration is 0. This is the advantage of doing relative motion in projectiles. So now you can see this body A will move in a straight line. There will be no acceleration of B as observed by a person in that frame. So for him, he will find that this body is moving just in a straight line, nothing else. और अगर उसे वो straight line में चलते हुए दिख रही है तो उसको बिल्कुल ऐसे जाते हुए दिखेगी. And when will this body moving in a straight line, and what is that straight line direction? That direction is this velocity of B as observed by A. This will tell you what is that direction. You will be saying, you will calculate the values. You know this component is this. Sorry. You know this component is this, and this component is this. So you know the angle with which it is moving, and it is moving in a straight line. So B, see the beauty of this relative motion in projectile. A is the observer, and he's feeling that B is not having any projectile motion. It is moving in a straight line with this velocity, this velocity, this velocity, and acceleration is 0. So it becomes a straight line motion question. If I ask you what is the closest distance, it becomes so simple to answer. Just see this. Drop a perpendicular from here and you will get the answer, this thing. And you know this theta. How do you calculate this theta? How do you calculate this theta? Can anyone tell me? So rest all is geometry. And I'm expecting that you have understood the crux of this. Okay, how beautifully relative velocity, relative motion study can make your projectile motion appear to be just a straight line motion. A will find B is moving in a straight line in this direction. He will not see any. So in his reference frame, in his brains, he will find B to be moving along a straight line as shown in the figure, along the green line, and then finding the closest distance will be AG. G is this point, and you drop a perpendicular, and then rest is geometry. You know this angle, this is 200 upon whatever. These angles, these velocities will help you find the angles, this and this. They will help you find the angles, and using those angles, you will be able to find, using geometry, this distance, and you will be able to do the questions. Now, okay. Rishit Bhagwat, I am happy. I do not want to get into solving the numerical. I just wanted you people to understand how relative velocity usage, finding relative acceleration, can immensely help you and make your projectile motion appear to be a very simple motion. And because both the bodies have the same acceleration, so the relative acceleration becomes 0. And there are some IIT problems which have come, and I don't think circular motion and kinematics of circular motion, or रोटेशनल मोशन के लिए ये बहुत इंपॉर्टेंट है. सो आई डो नॉट वांट टू डू इट बाय रशिंग, बिकॉज यहाँ से सीरियस गेम शुरू होगा. यहाँ से पूरा रोटेशन, फ्री बॉडी डायग्राम्स और वो सब चीजें होंगी. एंड आई वांट टू डू इट प्रॉपरली, तसल्ली से. सो आई विल कवर द नेक्स्ट लेक्चर फ्रॉम हियर. सर्कुलर मोशन से शुरू करेंगे. एंड we will be ending this lecture here today. Dear students, I hope that there is something that I was able to add. In the next lecture, I will be doing a brief, the kinematics part of circular motion. What is that acceleration, centripetal acceleration, and how, if you are, what are the angular velocity and kinematics of circular motion? And after doing that, we will do all these things: angular displacement, angular velocity, angular acceleration. This is going to be the basis of your rotation. So it's a very, very important topic. Please don't miss this. We'll do uniform circular motion, non-uniform. We'll also understand centripetal force, and I will also explain to you what is the funda of this thing, pseudo force. So in the next lecture, we will do the remaining parts. And till then, goodbye to all of you. And I will try that in the next lecture, what we can do is we can have a longer lecture, but I will do that only when I see students participating and responding. So when I see very few students participating and responding, it doesn't give me enthu. So thanks. Yeah, I can do Prerna, do the geometry also. If you are insisting, I can do the geometry also. Okay. But let's see. Let's go back. One child is requested, okay, please do the geometry part also. It's my duty, I should. Let's go back to that page. I can directly go there. Okay. Here. So now let's make this diagram proper, neat, and then try to do it. Okay. So this I know. One sec. I will just try to make it neat, because we found the relative velocities and we can do away with the unnecessary stuff here, which is written. Okay. So that I get space. Okay. Okay. We will utilize this space and solve this. So, dear child, you insisted that I should do the geometry part of it, and let's do that. So, this angle, let's find out what is this angle. Because, or this angle, let's find out whichever angle you want to. We know the component of velocity in this direction is 50. We found out the relative velocity of B as observed by A, VBA. It was this. If you see, the vertical component is minus 50. The horizontal component is this. And can I write it as some approximate value so that it becomes very easy for you to calculate? Or I can just say, using this and using this, just pay attention. I can plot them here, and I said that this is 50 and this is that value, some x value which came. And based on that, I can find tan theta. Tan theta will be how much? Tan theta will be as shown. This is theta. This angle is theta, which this line is making. 1 second. Let me make it a little neat. Again, I'm finding it hodgepodge. थोड़ा सा रब करते हैं इसको. Now, ये पॉइंट बी है और बी की इधर आ रही है 50 डाउनवर्ड्स और इधर आ रही है ये वेलोसिटी ऑफ बी एज ऑब्जर्व्ड फ्रॉम ए. और इसका मैं कुछ वैल्यू रख देता हूँ. 50√3 is 1.732 into 50. हाउ मच? प्लस 200. तो उसको कुछ एक वैल्यू तो बता दो मुझे. 17, 85 285 minus 285 roughly. So suppose this is 285, this is 50. So I can find this angle theta. I am doing an approximation. Now, this is theta. Tan theta will be, tan theta will be, tan theta will be 50 divided by 285, which is like 200 plus 200 plus 50 root 3. Now, tan theta we know. If we know tan theta, we can find sin theta cos theta. Okay. Now, in this triangle, in this building's height was 200. This building's height is 100. So this height is 100. This height, please pay attention. This height is 100. This is 100 meters, the height of the building above this level. Now, if I know this as theta, so I can calculate, I can just do, if I know tan theta, I can find the equation of this line, this line. I can write the equation of this line. The equation of this line can be written as, I know the slope of this line. If this angle is theta, this angle is theta, and tan theta represents the slope of this line, and that slope of this line is this. Slope of this line m, and there is a point that you know, which is, if this is the origin, this is the x-axis, this is the y-axis, you know this point. This point is how much? This point is 1 kilometer, yani ke 1000, 200 x, y. So point slope form mein you will be able to get the equation of this line. All of you must have done coordinate geometry in your 12th. Now, you can find the equation of this line. And when you want to find the perpendicular distance from a given point, and this point is 0, 100, you can find the perpendicular distance from this line. The equation of this line is y is equal to mx, m, you know the form, yaar, m y2 minus y1, y minus y1 is equal to m is equal to y minus y1. Y1 is 200 upon x minus x1 plus c, whatever. So this is how you'll use coordinate geometry. Find the equation of this line, you know the slope and one point, and from that line you find the perpendicular distance, and that is your mathematics. And please don't make me work hard, and I request all of you to use your math skills and solve this. Thank you so much. Great. Thank you, everyone. We'll do the next class. Thank you, Aryan. Thank you, Prerna. Everyone, thanks. Thanks, everyone. We'll do the next lecture, rotation, circular motion, pseudo force, and move to the free body diagrams and other topics. I will ensure that within a month, I am able to cover your full mechanics and ensure that you learn. Thank you. Thank you. Thank you, children. Thank you. We will connect in the next class now. Thank you so much for being patient, taking interest. Thanks.